Hi students, now let us solve the problem number 6. Determine the current flowing through the 3 ohm and 4 ohm resistors of the circuit given below. So the 3 ohm resistor and the 4 ohm resistors are given here. Through this, how much current is flowing is a question. Assume that the diodes D1 and D2, okay, D1 and D2, they are ideal diodes. We have to assume that they are ideal diodes. So what is an ideal diode? We have discussed many times. There is no potential drop across the diodes. Normally silicon diodes, had they given here silicon diodes, means what should be the internal potential barrier? That is 0.7 volt. This 0.7 volt is an opposing voltage. But this time we need not apply that because the ideal diodes okay, does not have any potential drop across them. Okay students, now let us analyze the circuit. The positive of this battery is sending a current of I ampere up to this junction. At this junction, this current is dividing in the left side path, closed loop is there I1 ampere, and the right side loop, let us take the current is I2 for example. So that by applying Kirchhoff's first law, I is equal to I1 plus I2. Okay, now what is the status of the two diodes D1 and D2? Are they both forward biased or reverse biased? Let us check now. The positive of the 12 volt battery is connected to the P region of the diode D1. So this diode D1 will conduct because it is forward biased, positive to P region. Whereas the positive of the battery is connected to the N region of the diode D2. So D2 is reverse biased and it will not conduct. Have you understood the concept first? Which of these two diodes will conduct is D1. So only D1 is going to conduct and D2 is reverse biased. It will not conduct. Okay. So the current I2 must be equal to 0. Current I2 must be equal to 0. So I can write therefore I2 is equal to 0. What is the reason? Because D2 does not conduct. Okay, D2 does not conduct. Therefore, the current through this entire branch is equal to 0. So we can erase that part itself. We can erase this now because there is no current in this part. So the circuit gets reduced. It is simplified now. Very simple circuit, is it not? So the current I1 is passed through the diode D1. So here, so this is equal to 12 volt. What is the total resistance in this path is 2 plus 4 is 6 ohm. Is it not? So here resistance is equal to 2 plus 4, that is equal to 6 ohm. Applied potential difference is equal to 12 volt. Therefore the current I1 must be equal to what? V by R. So this is equal to 12 divided by 6, that is equal to 2 ampere. Okay, therefore I1 is equal to 2 ampere. This is only asked, is it not? Find the current flowing through the 3 ohm resistor. The 3 ohm resistor was in the right side part of the circuit. What current must have flown through that is 0. And through the 4 ohm resistor as well as this 2 ohm resistor also. Suppose in the same question, what is the current flowing through the 2 ohm resistor? Had they asked 2 ohm as well as 4 ohm. Both are in series. Therefore, same current I1 equal to 2 ampere only must have flown. I hope you must have understood well. Fine.